April 5th, 1815. Mount Tambora rises peacefully above the Indonesian islands. For thousands of years, it has slept. That peace is about to end in the most violent way imaginable. Deep beneath the mountain, magma that has been building pressure for centuries finds weaknesses in the rock. The volcano begins to wake. On April 5th, villagers hear the first rumblings. Small earthquakes shake the ground. They've lived here for generations, but none have seen what's coming. Scene 4, April 10th, 1815, 7 p.m. The mountain begins its eruption, but this is just the beginning. The volcano is saving its true fury for later that night. At 10 p.m., Mount Tambora explodes with the force of 800 megatons, the largest volcanic eruption in human history. The sound is heard 1,600 miles away. Pyroclastic flows, avalanches of superheated gas and rock traveling at 450 miles per hour, erase entire villages in seconds. 12,000 people die instantly. When dawn breaks, the landscape is unrecognizable. Ash covers everything 3 feet deep. Entire islands have vanished beneath the debris. Another 70,000 will die from starvation and disease. 100 cubic kilometers of rock and ash are ejected into the stratosphere. The debris begins to spread, circling the entire planet in the upper atmosphere. In the weeks that follow, sunsets around the world become spectacularly vivid. Sailors report skies they've never seen before. The ash is spreading globally, but no one understands what it means. 20 million tons of sulfur dioxide form a reflective veil in the stratosphere. This aerosol layer will stay suspended for years, reflecting sunlight back into space before it can warm the Earth. March 1816. In New England, farmers prepare for spring planting. They don't know that winter is not truly over. They don't know summer will never come. A raven watches from a fence post. Like all creatures that year, it will witness something unprecedented. A year when the seasons forget their order. But spring doesn't. Temperatures stay below freezing at night. Snow that should have melted weeks ago remains on the ground. The trees won't bud. Farmers plant anyway. They've survived hard springs before. Seeds go into ground that's far too cold, but there's no choice. If they don't plant, there will be no harvest. May brings no warmth. The sun appears dim and sickly through a persistent haze. Scientists will later realize the volcanic aerosols are blocking sunlight from reaching the surface. When seedlings finally emerge, they're met with killing frosts. Frost in May is unusual. Frost in late May is disastrous. The plants die as they sprout. For scavengers, the strange year brings only more hardship. The frozen ground hides what little food exists. Even the ravens begin to struggle. Families burn firewood in late May, something that shouldn't happen. They're wearing winter coats as June approaches. The almanacs are wrong. The seasons have stopped working. June 6, 1816. Snow falls across New England. Not flurries, heavy snow accumulating inches deep. It's early summer and winter has returned. Nothing like this has ever been recorded. The June snow kills whatever crops manage to survive May. Corn, wheat, potatoes, all freeze in the ground. This isn't a bad growing season. This is the complete failure of agriculture. Europe faces the same crisis. From Ireland to Switzerland, crops are failing. Temperatures are 5 to 7 degrees below normal, enough to devastate agriculture across an entire continent. European wheat harvests will be down 75% this year. In some regions, there will be no harvest at all. Millions depend on these fields. They're watching them die. Ravens cross borders. Humans have drawn on maps. From New England to Europe, they see the same thing. A planet refusing to warm, crops refusing to grow, and hunger spreading everywhere. July 4th, Independence Day, and there's frost on the ground. Celebrations happen in winter coats. 40 years after American independence, nature itself seems to be declaring its own independence from normal patterns. Some farmers try planting 3, even 4 times. Each time, frost kills the seedlings. They're running out of seed, they're running out of time, and they're running out of hope. Food prices explode. Wheat that costs $1 a bushel now sells for $3 if you can find it. Oats increase 500%. Riots begin in European cities. People are starting to starve. Scavengers wait. Livestock are already dying from lack of feed. The ravens know what's coming. They've seen famine before, though never like this. September arrives. In a normal year, harvest would be underway. This year, there's nothing to harvest. The first snow of the coming winter is already in the forecast. In Europe, hunger turns to rage. Food riots break out across Germany, France, and Switzerland. Grain merchants are attacked. Stores are looted. The social order begins to fracture. People eat grass, tree bark, cats, dogs, anything. In Switzerland, reports emerge of darker acts born of starvation. This is what famine does. It strips away everything but survival. Typhus spreads through malnourished populations. The famine kills through starvation, but also through disease. In some regions, death rates triple. Ravens thrive in times of human death, but even they sense something wrong. This isn't the natural cycle of seasons and harvests. This is a planet malfunctioning. At Lake Geneva, a group of writers takes shelter from the endless cold rain. Lord Byron, Percy Shelley, and Mary Shelley spend the summer indoors. They can't remember the last time they saw the sun. Byron proposes a contest. Each will write a ghost story. From this dark, sunless summer, 18-year-old Mary Shelley will create Frankenstein, a tale of unnatural creation born from an unnatural year. The year without summer creates one of literature's greatest monsters. Frankenstein's creature is abandoned by its creator into a hostile world, much like humanity felt abandoned by nature in 1816. Scientists scramble to understand. They measure the weak sunlight. They note the persistent haze. They record the temperature anomalies, but they don't yet know about Mount Tambora, won't know for years. November brings real winter, the normal winter that follows the summer that never was. For those who stayed, the worst is yet to come, getting through the cold months with no harvest stored. Those who survive eat once a day. Portions shrink weekly. Children cry from hunger. Parents make impossible decisions about who gets what little food remains. The famine divides societies. Those with money can buy the scarce food available. The poor starve. The middle class watches their savings evaporate, purchasing bread at 20 times its normal price. When even the scavengers struggle to find food, you know the crisis is total. The raven survives on instinct and luck, resources that are running thin for every living thing. Churches fill with desperate prayers. Is this God's punishment? The end of days? In an era without scientific understanding of global climate systems, supernatural explanations seem as reasonable as any. A few scholars begin connecting the dots. Reports from New England match reports from Europe. Asia experienced the same cold. This wasn't regional bad weather, this was something global. February 1817. The volcanic aerosols are finally settling. Temperatures begin slowly to normalize. The stratospheric veil is thinning, the earth is beginning to heal itself. Farmers return to their fields. They have no choice. But this time there's less hope and more fear. What if it happens again? What if summer doesn't come this year either? April 1817 brings real spring. Trees bud on schedule. Temperatures rise normally. The ground warms. After nearly 2 years, the seasons remember their rhythm. The ravens notice. Food becomes available again. The natural world, resilient and patient, begins its recovery from the planetary wound. May 1817. Crops grow, the harvest will come. But no one who lived through 1816 will ever take summer for granted again. June brings warmth, real, normal, blessed warmth. People who lived through the previous June, when snow fell, step outside and weep with relief. The 1817 harvest succeeds. Barns fill with grain. Root cellars store potatoes and vegetables. Humanity has survived, but barely, and with scars that will last generations. The death toll will never be fully counted. Hundreds of thousands in Europe, tens of thousands in North America, millions more worldwide from the ripple effects. In the following years, scientists begin to piece together what happened. Letters arrive from around the world describing the same anomalies. But the cause remains mysterious. They can see the crisis was global. They can measure its effects. But in the 1820s, the connection to volcanic eruptions is not yet understood. In 1825, a Dutch explorer visits Tambora and reports its complete destruction. The entire top of the mountain is gone. But the connection to global climate won't be made for decades more. Survivors tell their stories. The year becomes legend, but they emphasize one truth. It was real. The Earth can change in an instant, and survival is never guaranteed. The natural world forgets faster than humans. Within a decade, ecosystems recover. But the event left its mark in tree rings, ice cores, and the DNA of populations that survived. The crisis drives innovation, better crop storage, and diversified planting, early food preservation techniques. Humanity learns redundancy and preparation are survival tools. By the 1840s, scientists began making the connection. Major volcanic eruptions can affect global climate. Tambora becomes a case study in how Earth systems interconnect. Modern scientists would later find the event perfectly preserved in ice cores from both poles, a frozen record of the year the Earth's climate system was knocked off balance. Tree rings tell the story too. The 1816 ring is barely visible, a year of almost no growth. Trees across the northern hemisphere bear this scar. Hundreds of personal diaries survived. Farmers, merchants, children, all describing the same impossible reality. Summer never came, and the world turned against them. Ravens can live 40 years. One that was young in 1816 might still be alive in the 1850s, the only witness to both the catastrophe and the full recovery. Mary Shelley's Frankenstein is published in 1818, a lasting cultural legacy of the year without summer. The novel explores themes of creation and abandonment, born from humanity's experience of a hostile world. Artists captured the strange skies too. J.M.W. Turner painted vivid, almost surreal sunsets in this period. Accurate depictions of light filtering through volcanic aerosols. Modern temperature reconstructions show 1816 clearly, a sudden drop of 0.4, 0.7 degrees C globally. That seems small until you realize it collapsed agriculture across 3 continents. Tambora's volcanic explosivity index was 7, the only eruption this powerful in the last 2,000 years. Krakatoa in 1883 was VEI 6. Mount St. Helens was VEI 5. Tambora was in a category by itself. Today, Mount Tambora stands 9,150 feet tall. Before 1815, it was over 14,000 feet. The eruption literally removed the top mile of the mountain. Modern climate scientists study Tambora intensely. Understanding how volcanic eruptions affect climate helps us model future impacts and reminds us how quickly global systems can change. We now monitor every significant volcano on Earth from space. If another Tambora-scale eruption begins, we'll know immediately. We can't stop it, but at least we won't be surprised. Modern strategic food reserves exist partly because of lessons learned from events like 1816. We maintain buffer stocks because we know crop failure can be sudden and total. Ravens are still here, watching. The species that witnessed the year without summer still flies over the same lands, now with modern farms, climate monitoring, and 7 billion more humans. We can now simulate exactly how the Tambora aerosol spread. Computer models show the sulfur dioxide converting to sulfuric acid droplets, circulating globally, persisting for 3 years. The chemistry is understood now. Sulfur dioxide plus water plus oxygen creates sulfuric acid aerosols. These tiny droplets are incredibly efficient at scattering sunlight, the planet's accidental sunscreen. The aerosol layer reduced incoming solar radiation by about 1%. That's enough to drop global temperatures and completely disrupt the growing season across temperate zones. Satellites now watch for thermal signatures of magma movement. We track gas emissions. We measure ground deformation. We're trying to avoid being blindsided again. Governments plan for the next major eruption. Food reserves, agricultural contingencies, communication strategies. Because Tambora taught us it can happen, and we might have only months to adapt. Our food system is now global. That brings resilience. Failure in one region can be compensated by others. But it also brings vulnerability. The whole system is interconnected. We store seed samples in Arctic vaults, genetic insurance against whatever disasters might come, including volcanic winters. The memory of 1816 helps justify these investments. Historical markers now stand in places hardest hit. They tell the story to new generations who never knew hunger, who've never seen summer fail to arrive. The story is taught in schools now, a lesson in earth science, history, and human resilience. Every generation should know the Earth's systems can shift rapidly, and civilization hangs on threads we barely notice. Conservative estimates put the death toll at 100,000 or more. Some scholars suggest it could have been several times higher when counting indirect deaths globally. The true number will never be known. The 15,000 climate refugees who fled New England in 1816 weren't the last. Climate drives migration still, and as the planet changes, we may see that pattern again on larger scales. The skies that the volcanic aerosols created were hauntingly beautiful. Spectacular reds and oranges. Nature's devastation came wrapped in visual splendor, a reminder that beauty and danger often intertwine. At Tambora, memorials now honor the 12,000 who died instantly and acknowledge the global ripple that changed history. The volcano that killed locally affected the world. The mountain lost 4,600 feet of height, over a third of its total elevation, in a single night by an asatitiwana. The physical scar on the landscape matches the historical scar on human civilization. Today, descendants of those who survived visit memorials and historical sites. The genetic legacy of those who endured has implications. We're all descended from populations that survived crisis after crisis. The ravens are still here, still watching, carrying in their DNA the memory of survival. And we remain on a planet where volcanoes sleep beneath our feet, where the climate system can shift in an instant, where summer, despite all our technology, is never truly guaranteed. The year without summer reminds us we live at nature's mercy, and that mercy can be withdrawn without warning.